negative pi over 2 and then ends with.
Because what does tangent by itself do? Starts at negative pi over 2, ends at pi over 2.
Okay.
And then I'm going to shift it, yeah? So what we're able to do with sine and cosine, we can always say it begins when the inside's 0, because that's what the base function does. It starts at 0.
Right.
So the base function is always going to start at negative pi over 2 for tangent, end at pi over 2.
Right. So same rule, just different.
Same idea, different values. Yeah. I'll be right back. Can you guys see one thing I could do right off the bat is, this sounds terrible to say, but kill the pi. Do you guys see that? Everything's got a pi. So if I divide everybody by pi, they all cancel. So now I just get 1/3 minus 1/2. What's 1/3 minus 1/2? Real quick, guys. What's the only time you can officially, directly cross multiply? If I have one fraction equals 1 fraction. You with me? You with me? People cross multiply too often. But let me show you a neat little trick. When you're subtracting two fractions, what's 2 times 1?
2.
What's 3 times 1?
3.
2 minus 3 is?
-1.
And put it over the product of those. Now, of course, if you do it a long way, 2/6 minus 3/6 is -1/6, yes? Those numbers weren't that bad, but that little trick I just showed you always works. If you don't want to use it, that's fine. I don't care. I don't get any royalties if you use it. So. Did you guys get the ending? I wasn't going long enough, probably. Now I'm going to add 1/3. So I do exactly the same. 2 plus 3 is 5 over 3 times 2 is 6.
For beginning.
Or 2/6 plus 3/6 is 5/6. Same thing. Yes.
For the beginning,
Yes.
when you add pi over 3, shouldn't it just be negative pi over 2 plus pi over 3?
Sure. Yeah. Sure.
So wouldn't that? Oh, I know.
So it'll be negative
Yeah.
half plus positive 1/3. I just wrote it that way. Is everybody at all with me? What's up, Serena? You good? Listen, I'm sorry. Don't focus on the little shortcut I was telling you. You can just make it 2/6 plus 3/6 is 5/6. Ooh. Just when the numbers get gross, that little shortcut's kind of nice. On this one, it's just make them both over 6. Who cares, right? You can do that. Yes?
Can you show how to draw 5, 6 again?
The way that I did it?
Yeah.
Okay. It's kind of like cross multiplication, but it's just a creative use. 2 times 1 is 2. 3 times 1 is 3. 2 plus 3 is 5, and you always put it over the product of the bottom. It's a shortcut.
Does that only work for 2 terms?
Yeah. But if you have a bunch of them, you can just kind of do it to pairs until you know. So like I said, do you suddenly have to be able to do that little shortcut? No, I don't care. But I like to tell you.
How come it doesn't match the phase shift?
Yeah, that's why we have to do the beginning end. So listen, guys. What two things are happening to this poor function? Primary things. Aren't I moving it? Yes? In fact, we figured out how much we move it, right? 1/3. Aren't I also compressing it? How did I tell? How do I know I'm compressing it? Because you made the problem, Jeff. Well, true, but how do you know I'm compressing it?
Next x.
That's bigger than 1, yes? So it's going to be like 1/pi. It's going to compress it. So I am compressing it and then moving it. So what you just said is perfect. If you just look at this, you think I'm supposed to start at 1/3, don't you? But I really want you guys to get this. If I normally start at 0 and then I compress, did 0 change? And then I apply the phase shift. That's why the phase shift was where I start. If I am at -pi/2 and I compress it and then I shift it, do you see how I'm not going to be where the phase shift says I'm going to be?
Because you're not starting at 0.
Because not only am I moving it, I'm also compressing it. So yeah, I moved it by 1/3, but then I compressed it, so now it's a 1/6. I don't know that unless I do the begin and end. So I really love that you asked that question, because I might have forgotten to point it out. That will not tell me where I start. That tells me where I start. Why will that not tell me where I start anymore? Because it worked for sine and cosine because they start at 0. Does this start at 0? No. So its beginning place is affected by a stretch or a compress.
So is that
Is there even any purpose of the phase shift?
Well, I still want to know how much is phase shift.
Oh.
In general, that's something we want to know. Like if I'm designing noise canceling headphones, I need to actually program to know how to phase shift the other frequency. I showed you this yesterday, did I? Did I show you this? The destructive interference? Serenity, thank you. You help me maintain my serenity. So I have to know how much to phase shift the wavelength that the headphone creates to counter what it's bringing in, so it cancels the noise. That's such a beautiful noise canceling headphones. It creates a wave function that cancels the other one. So mathematically it does exactly what the title of it says. So I have to know how much things are phase shifted, so I have to be able to program the formulas into my software in the noise canceling headphones. So yes, the phase shift doesn't help us to graph it, but you still have to know how to find it. Okay. What do I do now? Yes. So I'm going to start at -1/6. Now here's the trick with this. What's my step size? 1/4. So here's where you have to just extend the idea we used before. What's the LCD between these two? Once I do this, you really see why I'm doing it. Huh? 12. So y'all agree this is 3/12? Yes? Do y'all agree this is -2/12? Just do you agree with that by itself? Some of you guys are looking at it like, what the shit are you doing? But just do you agree with that as being a true thing? So now if I say, I start at -2/12, and every step is 3/12. Now do you see how those jibe with each other? Take one step and where do I go? 1/12. Another step, I end up at 4/12. Another step. Another step at 3/12, yes? 7/12, and then one more step. Wait, how many steps? 1, 2, 3, 4. One more step. 10/12, which is 5/6, which is where we said we should stop. Yes. Even if you don't 100% understand it, do you understand the part where, since this doesn't start at 0, things are a little bit trippier? The beginning and end process becomes necessary, not optional.
So on sine and cosine, you point a graph at the phase shift, but on tangent and cotangent, the phase shift is just something you want to know, but there's no graphing.
Yeah, I have to be able to figure out in general, just to know how much is shifted from a normal tangent. But graphically, I have to do the beginning end to know where it really starts. Yeah. So what do I put at the ends?
Vertical asymptote.
Yeah, because it starts and ends at a wall. And you can look back at what we did, but what's it do on the first step in?
0.
Sorry, here. No.
Oh, it goes down.
So we started a wall. First step in.
Down.
-3, good. First step in. -3. Next step in. 0. Next step. +3. So it looks like a straight line, yes? But we know better. It's going to come like this. Oh yeah, Jeff, you figured something out. It's going to go like this. It's going to go like this. Oh my God. You have no idea. That's just such a simple, stupid thing, and it still sucks, but it's not bad. I should have made that a little more curvy, that's all right. It's just the curvature of tangent is so slight, it almost looks like a straight line in the middle. Yeah.
And then you put the same kind of error outside the two vertical asymptotes.
Yeah, I mean, technically, you probably should
Well, you need to do that in a test and not.
something, but I know we're just graphing one. But I do, you guys understand that it's going to repeat that same shape forever in both directions. How many walls are there going to be? Infinite walls. And between every pair of walls, there's going to be like cubish looking little dude. Yes? Where did we say we had to begin? -1/6. Yes? How do I take one step? Add 1/4. I don't want to add 1/4 to -1/6. So I make an LCD from the beginning. If I make them both over 12, now it's easy to add a step and add a step because everybody's over 12. So that's just being nice to yourself. Right? You could do the work every time. 1/4 plus -1/6 and then 1/4 plus what I just got. But why would you do that to yourself? Just make an LCD to begin with. And then you can add easy. We actually did the same thing before. We just normally had to only change the step size to match. Tangent's a funkier dude. Yeah.
We could just do that because it's a smaller fractions like the LCD.
Oh, it's just because 6 and 4 have an LCD of 12. That's all. Yeah. Cool. One quick little thing that I don't know if you guys know. What is 6 times 4? But 24 is not the LCD, right? What does 6 and 4 have in common? No. What does 6 and 4 have in common? 2. So if you take their product divided by the biggest thing they have in common, you get the LCD. 24 divided by 2 is 12. Of course, 6 and 4 we don't really need help with, but what I just said works forever for every fraction in existence. Okay. You guys all right? Sorry. Some of you guys are doing this. And some of you guys are just like, no, thanks for asking. All right. All right, let me pile on top of that. So let's look at cotangent. That's crazy. Can somebody, don't say anything yet. Don't say anything. Just think about where this guy's vertical asymptotes are not going to be in the same place. But they're going to happen for the same reason. Where's this guy's vertical asymptotes? Just think about it. Give me the one thing you need to know.
It's 1 over tangent.
Cosine over sine. Right? So, where are there going to be vertical asymptotes? Everywhere that sine is 0. Where's sine 0?
1,
0, pi, -pi.
Yeah, so what we choose is to go from 0 to pi. Now, every multiple of pi, it's going to be another wall. You guys with me? Because every multiple of pi is on what axis? 0, pi, 2 pi. Yeah, so of course sine's going to hate it there. So at every multiple of pi forever, there's going to be a vertical wall, vertical asymptote. But we choose this to be our main one, 0 to pi. Nope, that's it. Because we're only going to graph one image. Now, I will tell you this. Cotangent is going to look a lot like tangent. In fact, here, maybe I should have done this. Come back to this for a second. Let's kind of figure out. Do you see how tangent is 0 here? So when you guys said 1 over tangent, that's not a bad idea, because what would be here would be a vertical asymptote for cotangent, yes? Cotangent's 1 divided by tangent. Now, here's the weird thing. If 1 divided by 0 is infinity, what's 1 divided by infinity? 1 divided by really, really big is really, really small, right? What's 1 over 10 billion? Is that a big amount? I'm going to give you 1 divided by $10 billion. You're like, oh, yeah. I don't know. I could buy like 1/50th of a piece of rice. Thank you. All right, you guys. So the cotangent's going to be 0 here. It's going to have a wall here. It's going to be 0 there. Okay, but do you see how not the easiest thing to think about? But we can kind of get a few aspects of it. Okay, let's just do this. I'm still going to do 4 steps. What's right in the middle of this? Pi over 2. What's right in the middle of that? Pi over 4. That's 1 pi over 4, 2 pi over 4, so this is?
3 pi.
That's right, kids. 3 pi over 4. Keep calling you kids. It's too bad. There's my 4 steps for my standard, unshifted, untransformed cotangent. What is the cotangent of pi over 4?
1.
Positive 1, yes? So we already see kind of a difference here. It starts positive. And again, the first step in is controlled by that number. Do you see that? If I put a 3 there, that would have gone to 3. So it still has that same idea. What's the cotangent of pi over 2? Cotangent is cosine over sine. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. So cotangent of pi over 2 is 0. Cotangent of 3 pi over 4 is the same as this, except now I'm in the second quadrant, so it's going to be negative 1. So again, it looks like a straight line, but we know better. Jeff. Such a slight curve to it. It's crazy. That's actually probably the best cotangent I've ever drawn in my life. I'm glad you guys were here for it.
And we do, congrats on the cotangent, by the way. But, and then we do the beginning and ending this one too, right?
Totally. So, what's the main, besides the fact that the walls moved, does anyone remember how much sine and cosine are offset from each other?
Pi over 2.
90 degrees, pi over 2. Cotangent and tangent are also offset. Where was tangent's first wall? Negative pi over 2. So if I shift it by pi over 2 by 90 degrees, so cotangent and tangent are offset by 90. That's one difference. What's the other main difference? Just looking at the shape of it. It goes the other way. It's like a negative cubish. Yes? Do you guys see that? Otherwise, it's exactly tangent. It's just been flipped and moved over. Yes? Okay. And then we can do all the same shit we did earlier. Yeah. It's all the same shit. So you just have to know the base look, and then you do amplitude, phase shift, you have to do beginning and ending. Now, real quick, to be honest, where does cotangent start? 0. So I actually don't need to, but if I were you, I might just do it. Just get used to doing it so you don't forget to do it on tangent. I don't know if you guys are with me or not.
So on any, replace the with any,
So for tangent, it starts at negative pi over 2. So if I compress it and move it, it's not going to move just by what the phase shift says. Because it's going to be moved because of, do you see if I compress it, aren't I moving it? And then I also move it because of the phase shift. So the phase shift alone does not tell you where it ends up. So if you do the begin and end, it kind of does all that work for you. So you don't have to go, okay, and then that would be gross, trust me, because I've done that. So if you do the beginning and end work, it does all of that for you, which is crazy nice to believe. Did I have to, what did I say about the beginning and end work for sine cosine? Do you have to do it? No, it's optional. Same thing with cotangent. Why? Because they begin at 0. If I stretch or compress 0, what happens to it? It stays in the same place. And then the phase shift is exactly how much it moves. Now listen, if that still doesn't make sense, just do beginning and end for everybody, right? For sine and cosine, it's nice, and for tangent, it's necessary. So if you just do it all the time, you're golden.
Wait, so you don't need to do it for cotangent?
Sorry?
You wouldn't need to do it for cotangent?
Because it starts at 0.
But what about the end?
Huh?
But the end isn't.
Well,
Okay,
where
then
does
it's
sine and cosine end?
2 pi.
Okay, but we don't need to do it for that either. Okay. Yes.
Same question as
All right, let's do this. Let's do one cotangent example that's been shifted. Then we'll call it a day. Sure, we'll do 3 again. Why not? So, to cut to the chase here, does everybody have that sucker written down? What's the quote, unquote amplitude? 3. If I factor the inside,
1/2 x
a
over
1/2 comes out.
pi.
Pi. Good. Take a 1 out of the top, take a 2 out of the bottom, you get pi over 1, pi. So what is the phase shift?
Left pi.
Right pi.
Left pi. What's the new period? What was the old period for cotangent?
Pi.
Pi. And we can see it, again, we can see it.
So pi over 2.
Pi over
1.
1/2,
Oh, so 2 pi.
2 pi. Kick ass. So what's the step size? Let me see. Sorry. I'm going too fast, let me know. I'm going too slow, deal with it. How do we get the step size now?
2 pi divided by 4.
Yeah, the new period divided by 4. Yes. So step size will be 2 pi over 4, pi over 2. Let's do the beginning and end work, and then I'll show you at the end how it was optional. Okay. So begins for cotangent. Where does cotangent begin? 0. And where does it end? When the inside is pi. Good. So if I subtract pi over 2 and double, I get negative pi. Does that jibe with this? Do you see that? Left pi, I'm going to start at negative pi. Why does that jibe and tangent didn't? Damn screwy little tangent. Because I start at 0. 0 is not affected by compression and stretching. So what's the only thing that affects 0? I really want this to make sense. Look. Tangent again. Negative pi over 2, pi over 2, yes? If I compress it, didn't that move? And then if I move it, it moved twice. So I can't just look at the phase shift and go, that's how it moves, because that's not the only thing that's going to make it move. 0 to pi. If I compress it, does this move? 0 to pi. If I cut everything in half, does this change? I need, what's pi divided by 2? Pi over 2. What's 0 divided by 2? 0. That does not move. So it's the only thing that makes it move if I normally start at 0 is the phase shift. That's the only thing that would make it move. Now, do you have to really deeply understand what I just said? No. You could just do beginning and end all the time. It's not a bad idea to do because it kind of checks to make sure everything's right. Tangent, it's not only a good idea, it's necessary. Okay. Come here, you. So over here, if I double everything, I'm just going to do it because that's what I would normally do. You see that? I just doubled everything. to kill my fractions, die fractions. And that makes the equation easier to work with. You can always multiply to kill a fraction when you have an equation. Does that jive with our period? Where do we start? Negative pi. Where do we end? How far apart is that? 2 pi, and that was what our new period was supposed to be, yes? Okay. So what happens at the beginning? There's a asymptote. How big is my steps? 5 or 2. So let me do this to myself, or for myself, that's better. So now 1 step would get me to 5 or 2. 1 more step gets me to 0. Pi over 2. I'm just taking a step every time, right? 1 more step gets me to, which jibes with this guy, which jibes with what the period's supposed to be. Yes? It's cotangent, so I know here, first step in, it's going to be up here. And then it's going to be 0, and then it's going to be negative. And then I just fill in. I'm so excited about this stupid little thing I figured out. That's so dumb, man. I do this in other situations. I'll be all right. I'll stop talking. You don't understand. I do that in other places, and I've never done that. And I'm 53. Are you kidding me? I'll be all right. I'll get over it. Okay, so I got 5 minutes. Yeah. I did say that was going to be it, though, didn't I? All right, I'm not that evil. Yeah, that's plenty. So there's one more section in chapter 8. I am going to give you an updated homework sheet since I had to push the last test 2 days forward. I am going to update the homework sheet one more time. I'm going to give that to you next week, obviously. Okay, I'll see you guys then. Have a good weekend.
Basically, spent the whole class going over this, but I feel like I'm